Hello, today we're going to be talking about interfaces in Java. For classes, they can only extend and inherit behaviors for only one superclass, while a class can implement an infinite number of interfaces, which is a special property of interfaces. A class can extend and inherit from only one parent class, since for multiple parent classes, if there is a method with the same method signature, such as name or parameters in both, Java will not know which parent class's method should be called. An error would result because of this ambiguity. For example, the parent car class has a method called room, and the other parent car also have the same method signature of room. If child car extends both parent and the other parent car, what will the variable of x be? There's ambiguity. However, unlike parent classes where the method body is created in that parent class, interfaces have their method body created in the class that implements those interfaces. If both interfaces require implementing a method with the same name, parameters, and return type, the methods of the two interfaces merge and there will only be one method created. As there is a result of only one method, there is no ambiguity and it is clear which method should be called. As an example before, if the parent car wants a method of room and so does the other parent car, these two requirements can merge together to form one single method that is implemented by the child car, so there is no ambiguity over which method to call. Here's a brief overview of interfaces. All methods, variables, interfaces are public, since interfaces do not have a body and they must be completed by classes, which requires all the components to be publicly accessible. Interfaces cannot create objects like abstract classes and cannot contain a constructor. As such, interfaces cannot be instantiated. An infinite number of interfaces can be implemented by a class using the implement keyword, while only one parent class can be extended by a class, which uses the extends keyword. Classes that implement an interface will need to provide the functionality specified by the interfaces. Interfaces can extend other interfaces, so the interface will be the equivalent of merging the interfaces together. One interface can extend an infinite number of interfaces. Abstract methods in interfaces are always instance methods without a method body. They must be completed and overridden in the class that implements the interface. Otherwise, if all abstract methods are not completed, the class that implements the interface must be declared as abstract. Default methods are also instance methods but with a method body. They can be overridden in the class that implements the interface. Static methods are basically static methods with a method body, and they must be accessed using a dot operator beginning with the interface's name. Variables are always static, final, and public. They must be declared and initialized within the interface or else there will be an error. So why are we using interfaces in model cars? One reason is to achieve abstraction, or only passing on relevant details, as abstract methods in interfaces have no method body, which would not be relevant if each class that implements the interface has different method bodies. For instance, with the cars example, say that the drifting method in the sports car interface prints a different sound for each car. The zero error class, which implements the sports car interface, would have a drifting method printing out screech. However, another car, a Porsche 911, would have a drifting method printing out When the method body is different for each class, interfaces allow each class to create their own method while providing only relevant information to do so, the method header. Irrelevant information, like the method body, is left out. Interfaces allow for total abstraction if all its methods are abstract, with no implementation, no default or static method, and there are no variables. While abstract classes can do the same, interfaces are the best option for this example because of multiple implementations. Multiple implementations means that a class can implement an infinite number of interfaces, while extend from only one parent class. For cars, there are shared groups that do not have a direct hierarchical relationship. In the silver arrow example, it is a sports car, electrical car, and Mercedes car. Yet not all sports cars are electrical cars. Yet, not all sports cars are electrical cars. Not electrical cars are Mercedes cars, and etc. As such, one parent class for Silver Arrow cannot contain all the behaviors of sports, electrical, and Mercedes cars. As interfaces allow for multiple implementations, interfaces will be ideal for the Silver Arrow to have behaviors of many groups. Interfaces enable the Silver Arrow to provide the functionalities required by all groups it is part of. The Silver Arrow can implement the methods specified in the interfaces, abstract methods, if the methods vary from class to class, or it can inherit the methods from the interface, default or static methods, if the methods are the same throughout the group. Also, how the variables are public, static, and final in an interface are suitable for aspects that do not change. For example, brand or battery efficiency that are the same for every single car of that class. Here are my image sources. Now we're going into the interface examples with varying difficulty. This is a basic beginner example of our interface. What will be printed as a result? Well, firstly, the class cow implements an animal, so it needs to override the eat and make sound methods, which are successfully overridden in here and here. These two methods are both public and abstract, and also are both instance methods. In the main code here, after a cow called new cow is created, if it eats, it goes chomp chomp first, as specified here. Later it makes a sound of moo, which leads to the result of here. This is an intermediate example. What will be printed as a result of the code? Firstly, a new object called newBag from the BBQ Lay's Chips class is created. Then an instance buy_snack method is called, which prints purchase snack first, as in here. Then it calls eatSnack, which prints open bag. Then later it calls bite, which prints crunch crunch. Then it calls tasteSnack. Because of how BBQ Lay's Chips implements chips and BBQ flavor, so because of how this method is not present in this class, it will look into these two interfaces and see if it could find it. And as in BBQ flavor interface, there's a default method of there's a BBQ flavor, so this is printed. For the next print statement, we know it starts with it has a color of. For BBQ flavor.color, we know it refers to the static variable of red. So this is printed. Here is an advanced example. What will be printed from the code? Firstly, we look at the main code. Here we see that there's a dot operator with the interface name of electrical car being referenced. So the program will go into the electrical car and find if there's this variable, and it will set battery efficiency equals 0.95 as in here. And for brand, it will set it to Mercedes. And for int years, it will set it to 2029. So printing these, we'll get 0.95 Mercedes and 2029. After an object called newCar was created from the Silver Arrow class, a method of charge battery is called. This method prints charging the Silver Arrow, so it prints this statement. For this statement, the program will look into sport car interface and find a speed up method, which would print vroom vroom. For drifting, it would print street as here, and for Mercedes maintenance, it would print this statement here. Thank you for watching.